Good evening everyone, welcome to the homework portal. This is week number 4 and we are solving the 5th problem. This will be published on 27th of September 2024. Okay, so as you all know about the homework portal, this is one problem per day. So I will be posting one problem every day, and it is supposed you are supposed to solve this problem, and by evening the solutions for this will be posted over here in the YouTube. Okay, now let us begin with this. This question is for 11 marks. This question is from the chapter on data analysis. As you all know, in paper 1 and paper 2, we have a question. We have 15 marks allotted for paper 1 only exclusively for the data analysis. Okay, so towards it, let us start solving this. If you want to have an in-depth understanding of this data analysis, what you can do is you can refer to my data analysis chapter, or maybe that is been available in the link. You can go to my playlist and you can see there are 5 videos completely recorded on the concepts of data analysis, what concepts do we use, and at the same time some examples are also been provided. You can look into it. Okay, so now let us start with this problem. Anyway, I will be giving you the concepts also as we proceed. Right, so thermometer and electrical heater are thermally, okay, let me start the timer. A thermometer and electrical heater are inserted into small holes into a solid aluminium block. Okay, so it's a solid aluminium block. Thermometer is here. So there is a heater being given here. Power supply is given here. Why do you need a power supply here? Because to heat the filament, electric current is passed through it and it heats the filament and it comes out of it like this. So as a result of it, this gets heated up. Okay, next. The heater is turned on at time t equal to 0. Okay, the graph shows the variation of the temperature theta of the block with time t. Okay, what is the graph? The graph shows theta with respect to time t. Theta is nothing but temperature over here, right? So therefore, let me start this temperature versus time t. So you see there are some error bars being given and you have plots over here. Okay, the first thing in any problem related to data analysis is that they will ask you to plot all these points and get it. Okay, so anyway, whether it's asked or not, we are not aware, but anyway, let us first plot all of them to get a smooth curve here. Before even reading the problem, this is what I am doing now. Okay, so to understand what is the data, that's how it will be helpful. Okay, so we got a smooth curve. What is this curve called as? This is called as the curve of least square fit. Okay, then on the graph, draw the line of a best fit for the data. So that's what we have done also. It's also called as draw the line of best fit. See, though it is called as line of best fit, you can also draw, or whenever you have coordinates like this, you are supposed to draw a curve over here. Don't assume it is a line of best fit. So I am going to start from here, I am going to start here, I am going to draw a line like this. Some of them do it, okay, because assuming that it's a straight line. It's not a straight line, so you have to do something like this. Okay, next, because it says the line of best fit. What is best fit? Best fit means the line of best fit should pass through all the points which are indicated there. Estimate the initial temperature of the block. Initial temperature. What do you mean by initial temperature? The temperature of the block at t equal to 0. Right? So at t equal to 0. Where is t equal to 0? It's here. See, the readings comes only until here. So what should I do? I should take it carefully. I should take a scale here and then I should extrapolate this like this over here. Okay. What is the value it intersects here? This is going to be 15. This is going to be 17.5. This should be 18.5. So according to me, this is 18.5 degrees Celsius, right? 18.5 degrees Celsius is your initial temperature. Then suggest why the temperature of the block approaches a constant value. So let me write it down here. 18.5 degrees centigrade. Why does the temperature of the block attains a constant value? Where is the block here? This is the block here. After some time, you observe this will attain a constant value. Why does this happen? The reason is, what do you say here? First is you are heating, right? This is for 2 marks. First is you are heating. Heating increases thermal energy given to the block. Okay, which implies temperature increases. Do we see this in the graph? Yes, of course we do see this. See, we see this here. See, this has been seen over here. So it is increasing here like this. Okay, and then suddenly you see it is now constant here. What is the reason? Because if it is constant, see, when you are constantly giving thermal energy and temperature is rising, now you should expect a graph like this. You should expect a graph like this, right? But why suddenly it is deviating like this and becoming saturated like this? The reason is because somewhere it is losing some amount of energy to the surroundings also. So some energy is lost to the surroundings, right? If it is lost to surroundings, what should happen? Then this should now fall down like this. But why is it not falling? The reason is something like this. See, you have, let us say a friend of you gives you 10 chocolates in hand. Okay. Now what you do is you have 10 chocolates in hand, and another friend of you, what it is, he takes 2 chocolates. Okay. So if he takes 2 chocolates, you will have only 8 chocolates. Now once again, if 2 chocolates is not being given, the rate at which 2 chocolates are coming to your hand and the rate at which these 2 chocolates are moving away from you, if they are constant, that means the amount of chocolates in your hand will be always be 10, right? That is what is happening. So in other words, some energy is lost to your surroundings such that, that's what you write, such that the rate of losing energy is equal to rate of energy gained by heating, right? So this will give you 2 marks. Okay. And after this, if you still want, what you can write is, you can say, thus thermal equilibrium is attained. Do not write this in the first instance itself, because this question is designed for all those who do not know anything about thermal equilibrium. Okay. So therefore, so until here, this is simple logic, general logic. If you have studied about thermal physics, then you can write this one here. But we are assuming that you do not know anything over here. Okay. So therefore, this is not required. But still, if you write it, okay, it doesn't gain any mark over here. We expect you to write only this much over here. Right. Next question. When the temperature has reached a constant value, the heater is turned off. The graph shows a variation of the temperature theta of the block with time t. So theta versus time t is shown. Okay. It appears to be like a straight line, right? What is the question? Show that the initial rate, see, something is bolded over here, initial rate of the change of temperature of the block is approximately minus 4 Kelvin per minute, which means he is asking you to find out what is the slope at the initial, what is initial here? Initial means it is happening at this point, okay, at this point. Now find out what is the tangent here, what is the slope here. So let me take up this line and this line, okay. What is this value? This is 28, this is 29, this is 30. So this should be 1 degree centigrade. And what is the horizontal distance? See, horizontal distance 0 here, is 0.5 here, this should be 0.25 here, right? This should be 0.25. So therefore, that line corresponding to you is 0.25 here. This is 0 here. Now what is the slope here? Slope should now be equal to y-axis by x-axis. Difference in y by difference in x, which should be 1 degree Celsius divided by 0.25. Since it's a decreasing slope, so you will get a negative value here, which should be minus 4 degree, okay, Celsius. But since it's delta T over here, delta T is also equal to minus 4 degree Kelvin, and what is this unit here? Per minute, minus 4 degree Kelvin per minute, minus 4 Kelvin per minute. What is being asked? 4 Kelvin per minute. Okay, so we have got this correctly. Okay, now let us move on to the next question. The power of the heater is 52 watts. Power is given. The mass of the block is 0.85. Determine the specific heat capacity of the aluminium. So what is the expression for specific heat? Q is equal to mc delta T. Okay, what is m here? M is given, C is unknown, delta T. So how do I find the value of delta T? Let us take delta T. Now this is what? This heat energy, right? But what do I need? I need power, which means if I write this by delta T, divide this by delta T, I will also get this as mc delta T by delta T. Now what is delta T by delta T? Can we get it from the graph? We can get it from the graph, because this is your delta T and this is your small delta T. So what did you do? Delta T by delta T, difference in y by difference in x, what did you get? Slope over here, right? So this is nothing but delta T by delta T, which you got this is minus 4K. Okay. So what you do is you can put it over here. So now, where is it? It's here. It's here. So this should be mass. Let us substitute this value. So 52 watts. So let me put this value. 52 watts is equal to mass is 0.85. C we do not know. This is minus 4. I'll take only the magnitude of this. So therefore, this should be 4 Kelvin per minute. But you know, in SI unit, minute is not the unit, right, for time. So I should convert this into seconds. So I will write this as 0.85 C into 4 divided by 60 seconds. So let us find the value of C now. C should be 52 into 60 divided by 4 multiplied by 0.85. Okay. Now let me use my calculator. So this should be 52 star 60 divided by 4 is equal to so much divided by 0.85 is equal to 917.64. 917.64. What is this now? Joules per kg Kelvin is what we get here. But now you see here, this is two significant figures. This is two significant figures. This is a data analysis question. So B properly write the answer with the two significant figures. So therefore, this should be 917. I can write this as 920 joules per kg Kelvin. So I get the answer. Then the percentage uncertainty in the rate of change of C is 4%. Rate of change in C. In C, what is this now given to you? Delta C by C. Hey, just wait. Don't take delta C by C here. This is rate of change in C, which means what? He's talking about the question C here. What is question C? I tell you, it is delta T by T is nothing but C here. Okay. So therefore, okay, now let us see. So the percentage rate of change in C is so much. The percentage uncertainty in the power of the heater, delta P by P is equal to how much? 3%. 3%, and that is the mass of the block, and that's this 3 here, and then mass of the block delta M by M is equal to 1%. And then what is the absolute uncertainty in the specific heat capacity of aluminium? Delta C by C is equal to what? Okay, so we know that P is equal to MC delta T by delta T is what nothing but P over here. Now what I'll do is I'll call this as X over here. I'll call this as X because it's too much big, no? So this is MCX over here. Okay. So as a result of it, what is given to us now? It is given that delta X by X is equal to 4%. 4% over here. Now, what do I need here? I need the value of C. So what I do is I take C as a subject and I will write this as P by MX, which should now be delta C by C is equal to delta P by P plus delta M by M plus delta X by X. Some of you might commit a mistake showing that, okay, I will take delta P by P here is equal to delta M by M plus delta C by C plus delta X by X, and then you will transpose all of them to the other side, which is incorrect, because you know errors cannot become negative. Okay, relative errors will never become negative. So therefore, so you should never do that one. Always choose the subject as C, and from there you continue this. So therefore, when I do this, what is delta P by T? This is 3. What is delta M by M? 1. And what is delta X by X? 4. So therefore, the total answer is 8%. So the answer here should be 8%. Okay. Then write down the value of the specific heat capacity of aluminium, joules per kg Kelvin. Its uncertainty and its unit. Value is asking, not unit. I'm sorry, this is not the one. Value. What is the value of it? Where is the value? We found out this 920, right? 920 is the value of the specific heat, and then its uncertainty and its unit. Uncertainty. Now you see the uncertainty in this one is delta C by C is equal to 920. So delta C by TC is equal to 8%. So therefore, delta C should be 8% of 920, right? So what should I do? I should write this as 8 by 100 multiplied by 920. The 0 goes away. And now let me use my calculator once again. So this will now become 92 star 8 is equal to so much divided by 10 is equal to 73.6. 73.6, which is close to 74. Okay. So thus the value of C should be C equal to 920 plus or minus 74, then joules per kg Kelvin. When I am talking about the uncertainty and its units, what does it tell you? It tells you what is the full value here. Okay, so you need to get the absolute uncertainty here, right? Let us move on to the next one. Okay, done. We are done with it. Okay, fine. Thank you. I hope you are getting all the problems. So do like, share and subscribe to my channel for more updates. Every day I put at least something like 10 MCQs for IB and 2 problems, one for IB1 and other for IB2. So shortly I am starting a community in WhatsApp, so everyone can join into it. So there will be no good morning, good evening messages there. We can communicate, and if you have any doubts, any questions onto it, you can just post it across and I would be happy to answer to it. Okay, so we'll be doing it, and do watch this space regularly because shortly I am starting a new course. This course may not be monetary initially for the first few weeks. Okay, so if my subscriber counts crosses more than 1000 and my view count also increases, then definitely I'll be paid by YouTube. I don't expect any money from you guys, right? So therefore let us see to it that something happens really. It will also motivate me to do much more things. Already I'm doing well over here. So we have crossed nearly 1000 videos, and shortly my website will also be updated, and seeing to it that the myth, namely IBDP students cannot solve JEE problems, should be broken. That is what my idea is. I was JEE teacher earlier, so now this is what is my idea. So let me try it out. Okay, so slowly I will bring that culture into it and see that you can also get into IIT. Thank you once again for being patient and watching my video. Thank you.